everyone. I'm Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic Data Encryption Standard, that is DES algorithm. Data Encryption Standard DES is an example for symmetric key crypto system, which is developed by National Institute of Standards and Technology NIST, and it follows the Feastel cipher structure. So what is symmetric key block cipher? Hope you remember the same key is used for both the encryption and for decryption. If it is the case, this is called as a symmetric key crypto system. The general structure of DES algorithm is given in the figure. So we have the plain text as the input, so whose size is 64-bit, and it is given as the input to DES cipher. And for encryption we are using a 56-bit key, and we get the ciphertext, that is scrambled text. It is transmitted through the communication channel. At the receiver end we have the ciphertext. We are applying the DES reverse cipher using the same key, thus we recover the original plain text. So this is the general structure of DES algorithm. As I told, we have 64-bit plain text. Initially it is permutated using the initial permutation. Then we move with 16 rounds of operation. For each round the unique key is given, and these 16 keys are generated from our single input key, 56-bit cipher key, through the random key generator. And after performing 16 rounds, finally it goes with final permutation to get the ciphertext. So we have three main steps in DES algorithm: the initial and final permutation, and the 16 rounds, and encryption and decryption. So this is the overall diagram. So we have the input. First we go with the initial permutation. After the initial permutation it is divided into two halves. So 64-bit plain text, so it is divided into two halves, 32-bit, 32-bit, and our key size is 48. Okay, so it is applied with some function. After performing the function, the left and right half are swapped. Like this, we are repeating the same steps for 16 times. Finally, we go with one inverse initial permutation and we get the output. So this is initial and final permutation. So that is, the first bit is mapped to 48th position. Second bit is mapped to 8th position. Like that, we are rearranging the letters. After the initial permutation, we have 16 rounds, and finally we have one more final permutation. Okay, so initial permutation, this is how initial permutation takes place. So filling of this table is very easy. So 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15, 16. So like this you have to fill the entire table. And for final permutation it is also easy. The second column 1, 2, 3, 4, 5, 6, 7, 8, and the fourth column 9, 10, 11, 12, 13 up to 16. Then the next, leave the next column, go with the next one, fill 17 to 24, again leave one column, fill 25 to 32, move with the first column again and restart the process. So this is how the final permutation takes place. So what happened to each and every round? It is given here. So we have either the left half or the right half. So initially it is expanded to 48 bits. Why we are expanding means we are having a 48-bit key. So in order to apply the XOR operation, both should be of same length. So we are expanding our plain text to 48 bits, and we perform the XOR operation, then it goes to the S box, that is the substitution box, where each and every bit is substituted by some other bit. And finally we go with one permutation and we get the output. So how the bits are expanded, so it is shown in the figure. See, we have 8 boxes and each box consists of 4 bits, and how the expansion takes place, so like this. Okay, so now 2 more bits are added along with the original 4 bits. So this is how expansion takes place. And for expansion permutation we have a separate table, and we move with the substitution box. Here we follow one substitution box. Using this substitution box, every bits are mapped to substituted by some other bit. So how this substitution takes place, so this is one example. So our input is 10011. Okay, so how it is substituted by the other bit. So how we solve means, first we have to combine the first and 6th bit, that is 1 1, which is equivalent to 3 in decimal, that is 2 power 0, 2 power 1. So which indicates the row, that is we are going to search the value in row 3 and combine the middle 4 bits to identify the column 0 0 0 1, so which is 1. So row 3 column 1, so this is our right value, that is 12. So 12 is substituted. Okay, so this is how we are doing the substitution. As I told, from our single key you have to generate 16 different keys by using the shifting operation and the compression permutation. So how the shifting operation takes place means, for the rounds 1 to 9 16 the bits are shifted 1 time. For all the other rounds the bits are shifted 2 times. Okay, using the random key generator, 16 different keys are created and each one is used for each round. So this is the general diagram. So we have the initial permutation, then it is given for 16 rounds. Okay, after performing 16 rounds we do with final permutation to get the ciphertext. At the receiver end, we start with the initial permutation, then we go with 16 rounds, but the keys are used in reverse order. After the 16 rounds we go with final permutation to get the ciphertext. So with this I am concluding today's topics, DES algorithm. Thank you.